Welcome to DNA Learning Chemistry class. This is Shivani here, and I'm going to take the last part of chapter 1 of plus 1 chemistry, that is some basic concepts of chemistry. So in the previous part, we have already discussed the topics like empirical formula, molecular mass, empirical formula mass. So I'm just going to recap those ideas. Empirical formula into N equal to molecular formula, and N equal to molecular mass divided by empirical formula mass. Hope you are familiar with this equation, right? If you have the idea about these two equations, we can surely do the problem from NCERT, that is problem 1.2. A compound contains 4.07% hydrogen, 24.27% carbon, 71.65% of chlorine. Okay, its molar mass is given, and we are asked to find the empirical and molecular formulas. So first we are going to find the empirical formula. Okay, empirical formula means we need to know the number of moles, right, or the n value, the whole number. So divide the masses provided here, 4.07, 24.27, 71.65 with the molar mass. We are going to find the number of moles n. Okay, n. So divide the given mass 4.07, check the step given here. Divide the mass, given mass, by its molar mass. 4.07 divided by the mass of hydrogen is 1. The mass of carbon is 12. So 24 is divided by 12. The mass of chlorine is 35.5. So 71.65 is divided by 35.5. Hence we got 4.044. Let's round it to 4. Let's round 2.021 to 2 and 2.2021 to 2. So I cannot write like this. C2H4Cl2. I cannot write like this. I should divide it by a simple whole number ratio. Then I'll get CH2Cl, right? Dividing it by the simple whole number ratio, that is 2, I get CH2Cl. So this is the empirical formula of the given question. From this we can find the molecular formula. How do we find the molecular formula? Molecular formula means empirical formula into N. Empirical formula into N means molecular formula, right? See the equation here. Empirical formula into N means molecular formula. So for that we need to find the N value. Okay. So as to find the empirical formula, we have divided the given mass by molar mass. We have found out the number of moles. Okay. From the number of moles, we found the empirical formula. By dividing the number of moles with a simple whole number ratio, we got CH2Cl. So just divide the molecular mass by empirical formula mass. You will get the value of N. Okay, and molecular mass is already given in the question. Molecular mass will always be given in the question. 98.96 divided by the mass of CH2Cl is carbon 12 plus hydrogen 2 plus 35.5, 49.5. So this will, once you divide 98 divided by 49, you will get the answer, the value of N. Multiply it with the CH2Cl, you will get the molecular formula. Today we are going to learn a new topic, limiting reagent. What is a limiting reagent? A limiting reagent is a reagent that limits the quantity of the product formed. You know that a product is formed by mixing two or more reagents. Okay, while you mix two or more reagents in the presence of something that enhances the reaction, you'll get the product, right? If I mix hydrogen and oxygen, I'll get the product water or hydrogen peroxide, etc. So once you mix two reagents, you'll get the product. You know about that. So the limiting reagent is one among the reagents that is mixed, which limits the amount of product formed. Let's look into some examples. H2 plus Cl2. H2 means, this is H2, 2 atoms, 2 hydrogen atoms. Cl2. One H and Cl combines to give HCl. Another H and Cl combines to form HCl. So H2 plus Cl2 gives 2HCl. 2HCl. Now, shall we look into the second equation given here? Second equation, 2H2. 2H2 means 4 hydrogen atoms. 2Cl2 means 4Cl atoms. So you can combine this way, this way, this way, this way, and you will get 4HCl. 4HCl. Now coming to the third chemical reaction equation, 3H2 means 3H2 plus 2Cl2. 3H2 means 6 hydrogen. 6 hydrogen atoms. 2Cl2 means 4 chlorine atoms. This H and Cl combine to form HCl. This H and Cl combine to form HCl. Likewise HCl. This also HCl. What about these two hydrogen atoms? Is there enough chlorine to react with the remaining 2 hydrogen atoms? No, there is no chlorine enough to react with 2 hydrogen atoms. So the limiting reagent in this reaction is chlorine, because it limits the amount of product formed, or it's a reagent that is completely used up in a reaction. In the particular reaction given here, chlorine is completely used up. 2 hydrogen atoms are left. Chlorine is completely used up and there are no other chlorine atoms to react with the 2 hydrogen atoms. So in this reaction, chlorine is the limiting reagent. Let's look at the last chemical reaction given here, equation. H2 means 2 hydrogen atoms. 2Cl2 means 4 chlorine atoms. This chlorine and hydrogen combine to form HCl. Here also HCl. Here there are no hydrogen atoms enough to combine with chlorine, so which is a limiting reagent? Only 2 hydrogen atoms are there. It is completely used up in the reaction. So who determines the quantity of product formed, or which is a reagent that is completely used up in this reaction? Hydrogen is a limiting reagent. Yes, hydrogen is a limiting reagent. So you now understood what the concept of limiting reagent is, right? Coming to our problem. A reaction mixture for the production of NH3 gas, ammonia gas, contains 250 gram N2 gas and 50 gram H2 gas. Identify the limiting reagent and calculate the mass of NH3 gas produced. So first of all, you need to write the balanced chemical equation for the production of ammonia. You need to know how to write a chemically balanced equation. N2 plus 3H2 gives 2NH3. This is the balanced chemical equation for the production of ammonia gas. 2 nitrogen atoms are present in the left side of the reaction. 2 nitrogen atoms are also present at the right side. 6 hydrogen atoms are present in the left side of the reaction. 6 hydrogen atoms are present in the right side of the reaction also. So the equation is chemically balanced. Now, N2 means 28 grams, 3H2 is 6, so in total 34 grams, right? Ammonia, 28 plus 6 is 34. The given mass of N2 is 250 grams. Hydrogen is 50 grams. We need to find the limiting reagent and the mass of NH3 produced. So, how to find the limiting reagent? As per the chemically balanced equation, 28 grams of nitrogen requires 6 grams of hydrogen, right? As per the condition given here, as per the question, 250 grams of nitrogen reacts with 50 grams of hydrogen. So we need to find which is the limiting reagent, either nitrogen or hydrogen. So just multiply 250 into 6 by 28. 250 into 6 by 28. We'll see the mass of hydrogen that is required to react with the 250 grams of nitrogen. 250 into 6 divided by 28. 53.57. 53.57 grams of hydrogen is required to react with 250 grams of nitrogen. Do we have enough quantity here? Do we have enough quantity of hydrogen here? As per the question, 50 grams of hydrogen is also only there. So, which is a limiting reagent? Hydrogen is a limiting reagent. Yes, of course. How do we find the mass of ammonia produced? Just multiply 50 into 34 divided by 6. The answer will be the mass of ammonia that is produced. Coming to the last 2 topics of +1 chemistry, first chapter, some basic concepts of chemistry, that is molarity and molality. The same topics you'll be going to study in +2 also. So molarity and molality are two methods to express the concentration of a substance in a solution. Okay? So what is concentration? Concentration means the amount of solute present in a solution. Solute. You know that a solution is produced by mixing solute and solvent. Okay, I take a glass of water. I've mixed 1 spoon of sugar to it. So which is the solute and which is the solvent? The I've put sugar, right? Okay, sugar or salt, whatever. It is a solution, sugar solution or salt solution. So which is the solute and solvent here? Solvent is the component that is present in large quantity. I've taken a glass of water, right? And I've put some sugar into it. So water is in high quantity here, and so water is a solvent and sugar is a solute. Solute is a substance which is present in trace quantities in a solution. So molarity and molality are two terms or two methods to express the concentration of solution. Molarity means number of moles of solute to the volume of solution in liters. Okay, you know the volume of solution, then how do we find the molarity? You need to find the number of moles of solute present in that solution and divide it by the volume of solution in liters. Okay, let's see to the equation. See to the problem from NCERT, problem 1.7. Calculate the molarity of NaOH in the solution prepared by dissolving its 4 gram in enough water to form 250 ml of solution. So the equation is number of moles of solute by volume of solution in liters. Volume is already given here, 250 ml. But the volume should be in liters, right? 250 ml can be converted to liters, that is 0.250 liter. Now we need to find the number of moles of solute particle. How do we find the number of moles of a substance or something? Given mass by molar mass. Very easy. Given mass is 4. Right, 4 grams by the mass of NaOH. Mass of NaOH is 40. Okay, so just divide it and find the answer. The answer is already given here, 0.1. So number of moles by volume of solution in liters, 0.1 divided by 0.250. So the answer will be 0.45 molar. 0.4 molar. Capital M. Molarity, the unit is expressed in capital M, molar. Coming to molality. Molality is the number of moles of solute present in the mass of solvent in kilogram. Okay? In the same case of solution itself. I'm mixing a solute and solvent. Maybe the solvent is present in grams or kilograms. So I need to find molality, small m. It is expressed in small m. Molarity is expressed in capital M and molality is expressed in small m. So just simple. If you know the equation to find molarity, you are easy. You'll feel much easier to know what molality is. Molarity means number of number of moles of solute divided by volume of solution in liters, right? In the case of molality, you need to divide the number of moles of solute by kilogram, the mass of solvent in kilogram. The mass of solvent in kilogram. In the case of molarity, you have divided the number of moles of solute by volume of solution in liters. In the case of molality, you have to divide the number of moles of solute by the mass of solvent in kilograms. Let's do a problem. The density of 3 molar solution of NaCl is 1.25 grams. Calculate the molality of the solution. Very simple question. So you need, the equation to find the molality, right? Number of moles of solute by mass of solvent in kilograms. Okay? So the number of moles is already given, 3 molar. 3 molar means 3 moles of solution, 3 moles of solute. So now we need to find mass of solvent. Density is given in the question, right? Density D equal to mass per volume. So mass equal to density into volume. That is, density is already given 1.25 into, what's the volume? It is already given here, gram per, it's given in gram per milliliter, right? So 1 liter of solution means 1 liter of solution means, expressing in the case of grams, it is 1000. Yeah, obviously it is 1000. So multiply 1.25 by 1000 and you'll get 1250. 1250. So you already know that there are 3 moles of NaCl in the solution. Okay? In the solution, there are 3 moles of NaCl. So how do we find the total mass of NaCl in that solution of 1 liter? Total mass. So 3 moles of NaCl means 3 into the mass of NaCl, which is already given here, that is 175.5 grams. Okay, as per this equation, you will get the mass. Okay, you will get the mass in 1 liter solution, and as per this equation, you will get the mass of 3 moles of NaCl. Subtract it, that is 1250 minus 75.5. From here, you will get 1250 minus 175. 175. Here 175 is there. You'll get 1074.5 grams. So the number of moles is already given in the question. You just have to substitute the value of mass of solvent in kilogram. Mass of solvent in kilogram means the mass of solution minus mass of solute, right? Mass of solvent in kilogram. Sorry, mass of solvent means the mass of solution minus mass of solute. Mass of solute is found out by 3 into NaCl. Mass of solution is found out by 1000 into 1.25. The density equal to mass per volume. Density into volume gives mass of solution. So subtracting this from this 1000 into 1.25 gives you 1074.5, and that's the answer to the question. So by that, this chapter is over. The chapter of some basic concepts is over. So make yourselves thorough with the problems, the numerical problems from this chapter. For sure, you'll be facing few numerical problems which I've done in my session in your board exams. For sure, 100% sure. So listen the parts again and again, the part 1, 2, 3, 4, again and again, and make yourselves thorough with the numerical problems. We'll meet in another class. Till then, bye-bye.